Welcome to a short video comparing passwords to web keys as secure access control mechanisms. First, of course, we have to define our terms. I will presume everyone knows what a username password pair is, but what is a web key? A web key is a URL that uses HTTPS protocol, so it is encrypted, uses some mechanism such as a certificate authority or, as shown here, an embedded fingerprint to authenticate the site, and has an unguessable string of characters in the page name or the query string or the fragment that acts as a credential. The important rule of a web key is that the only way of reaching a resource designated by a web key is to have someone hand you the web key. The web key link cannot be guessed or intercepted. As a consequence, if you have a web key to a site, all you have to do is click the link to go to the site and go to work. There is no login page to navigate through and no username or password to remember or type. Now, web keys are easier to use than username passwords since you just click and go. But are they as secure? Securing a resource requires protecting the access path from numerous different kinds of attacks. You have to build a threat model for the resource and compare the access control strategies on all aspects of the threat model. On the one hand, every resource deserves to have a threat model built and analyzed for its particular context. On the other hand, many web-based applications face many of the same threats. So I've constructed here what I hope to be a reasonably typical threat model for a reasonably typical app. Your mileage may vary if your app has requirements not considered here, in which case you will have to build a better threat model. In any event, here is a decision matrix comparing 4 different access control strategies on a set of important well-known attacks. Let me explain the layout of the matrix. Across the top are the threat criteria, prioritized from left to right, with the leftmost threat being considered the most important and the rightmost threat considered least. Again, you may have to change these weightings for your situation. I'll explain the weights in a moment. Running down the left-hand side are the options, sorted according to overall excellence, with the current best choice located at the top. Let's talk briefly about the criteria. The major rule used to prioritize the individual threats is how many cyber thieves will be able to run this attack against you per year. A cyber thief here is defined as someone who, for fun or profit, would happily take your credentials so they can use your resources. Using this as a prioritization principle, it is easy to understand why phishing is weighted as the most important criterion. Phishing can be done by anyone in the world. It is a transcontinental attack vector that can be used against you from thousands of cyber thieves from Romania to Beijing. Worse, usable security research has shown that even people who have recently been given extensive training on how to avoid being phished are still vulnerable. These are the reasons that phishing is such a popular attack on the web today. The second most important criteria is the amount of authority stolen in a single breach. If a breach gives the attacker a great deal of power, the damage done by the breach is great. We can quibble over whether this should be ranked first, second, or third, but it certainly belongs up there. Third is the brute force or dictionary attack, in which the attacker tries to guess the credential that gets him access. Like phishing, it is a transcontinental attack open to cyber thieves worldwide. But it takes more computing power than phishing, and it can be claimed that a person can make himself invulnerable to these attacks by using strong passwords. Though because the human mind is so poorly designed for generating and remembering random character strings, this smacks of a far too common security strategy known as blaming the victim. Certainly your narrator is vulnerable to this attack, and no one will think less of you as a person if you confess to using weak passwords as well. Next is the pure social attack, in which the computer is used primarily as a communication medium through which the attacker will try to persuade you to surrender a valuable credential. The Nigerian hoax is a good example of a pure social attack. Anyone who has seen Robert Redford's movie The Sting will appreciate that these attacks can be quite elaborate. While such attacks are also transcontinental, this is the first attack in this list that you can really defend yourself against with a modicum of skepticism and a basic rule against sharing strong credentials. The attack also takes time and patience because the attacker must first establish a trust relationship with the victim, so it may be much more expensive than the higher ranked threats. Shoulder surfing is the attack where someone is watching your screen and/or your keyboard while you work. This attack is not transcontinental. Indeed, it does not even work all the way across a single room unless you are projecting for an audience. Orders of magnitude fewer cyber thieves have the opportunity to pilfer your credentials with this attack, which is why it is given such a low priority. Physical attack, in which the attacker gets 15 minutes or so of private time all alone with your hardware, is also available to very few cyber thieves, arguably even fewer than the ones who can shoulder surf, so it gets the lowest ranking. Okay, the options we can choose from in this limited comparison are, from bottom to top, single sign-on systems allow the user to have a single username password that he uses for everything. The advantage of this is usability. It is easier for the user to remember just one password rather than many. Numerous username password pairs are the normal method of access control throughout the world today, though various organizations keep pressing us to accept their one true single sign-on as the access path to all your stuff. Crude web keys are simply the kinds of unguessable encrypted links I described earlier. Current browsers are actively hostile to the use of web keys in certain ways, so our last alternative is web keys with browser support, which would have better security. So what are the justifications for the individual ratings? Clearly, passwords of both kinds deserve a poor rating on phishing, as a decade of experience demonstrates. Web keys, on the other hand, are actually invulnerable to phishing. The credential at the end of the URL is only revealed at the specific site where the credential is supposed to be used. To put it another way, since there is no login page, there is no opportunity to trick the user into delivering the credential in the wrong place. It just can't happen. Meanwhile, with respect to the amount of authority stolen in a single breach, most web keys, and especially the web keys exposed to users for sharing with others, are highly attenuated. See the PubShare video for an example of attenuated web keys. Single sign-on is, of course, the nightmare of single breach attack, since it surrenders all your authority everywhere in a single quick kill. Web keys use cryptographically strong random character strings for their credentials, making them effectively invulnerable to brute force attacks. This is very different from the reality of passwords, though in your own decision matrix you may want to bump up the score for the single sign-on password because, at least in principle, it would be easier for a user to remember one strong password than many. You would have to assess the nature of your expected user base to make a serious distinction here. Aside from the unguessable WebKey-like links we get from private videos on YouTube, private documents on Google, renewal subscriptions from CACM, paper referee links we get from IEEE software, and other WebKey-like links we get from a host of other sites, it is generally assumed that links and bookmarks have no security properties and you can just hand them to anyone you meet on the street. To the narrator, it seems likely that if we spent a fraction of the effort teaching people about web keys that we have spent failing to teach people about phishing, this could be overcome. But let us put the narrator's opinion aside. It is reasonable to presume that it would be relatively easy to persuade many people to give up Webkeys to a social engineering attack. So I have given Webkeys a poor rating here. Meanwhile, despite the fact that we have desensitized people to the sharing of passwords by forcing them to do such sharing just to get their work done, I have given the password choices a good rating on the social attack metric. As I mentioned earlier, modern browsers were not designed with unguessable WebKey-like links like those you find in YouTube in mind. Indeed, the browsers seem to get worse, not better, as they become more insistent about flashing URL gibberish in some annoying and distracting way every time you accidentally hover too close to a link on the page. From a shoulder surfing perspective, this is a disaster for raw Webkeys without browser support. Finally, neither passwords nor Webkeys give you any protection from physical attack. If a cyber thief gets 15 minutes alone with your machine, he can install a keystroke logger to snatch your passwords and a remote file reader to snatch your stored Webkeys. Techniques like disk encryption will work approximately as well and as poorly for both Webkeys and passwords, and all strategies for protecting credentials fail in the face of physical attack. There you have it. Full disclosure requires me to confess that I myself have for years believed Webkeys to be overall not only easier to use, but also more secure than passwords. So it is reasonable for you, the viewer, to suspect that I have allowed my preconceived biases to distort my analysis. And you may be right. Certainly, I myself could create a different decision matrix with different weights and ratings, and a deliciously twisted set of rationalizations to show that passwords are stronger. But neither of these things should make a difference to you. The important thing is that when you go to develop a threat matrix for the application you are building, do not let your preconceived biases distort your ratings. Keep your ratings undistorted, and expand your decision matrix so that it includes criteria for both usability and rich sharing to the extent that you need such features in addition to security. Only then can your application have the best blend of security, usability, and functionality that it can achieve. Thank you.